Welcome to this explainer brought to you by Forge College. I am absolutely pumped you're joining us today. If you were with us for the last lesson, you know we got our environment perfectly configured. Well, today we actually plug it in. We're building a literal code bridge from your local setup directly to the live Solana network. We're taking all that theory, all that installation, and turning it into working, executable action. Look, let's be real for a second. Every single developer, myself included, faces this exact moment of mild panic, right? You've installed Node, you've pulled down the packages, maybe you've got a local validator spinning, and, well, nothing has caught fire yet. But you're staring at your terminal, just kind of wondering, did I actually wire this thing up correctly? Is my code actually talking to the blockchain? It is completely normal to feel that way. Honestly, you're going to feel that way until you actually see real data flowing across your screen. So let's look at the schematic for today's build. Step 1, the connection blueprint. Step 2, reading on-chain state. Step 3, lamports-to-SOL math. Step 4, your first Web3 script. And Step 5, validating the setup. Nice and simple.
Okay, kicking things off with stage 1, the connection blueprint. We need to identify the absolute core component required to talk to the network.
Enter the connection class. You can really think of this object as the main heavy-duty communication wire of our whole operation. You just hand it your RPC URL, and it does the heavy lifting. It completely abstracts away all those messy, low-level HTTP and WebSocket requests so you don't have to deal with them. What you get back is this beautiful, clean pipeline that fetches the on-chain state and hands it right back to you in friendly, developer-ready JSON. It's literally the central hub for everything we're doing today.
Right, so once that main wire is hooked up, we move to section 2. Reading on-chain state. We're going to use public read APIs to safely peek at the data flowing across that new connection.
Now, when we check out the engineering specs for our read operations, there are a few different tools. We've got getAccountInfo for when you need raw binary data or metadata, and getParsedAccountInfo when you need human-readable fields like token balances. But the absolute standout is getBalance. It just returns a straightforward number. This is totally our go-to tool for today's read-only operation. It's super simple, incredibly fast, and it does exactly what we need to prove our connection actually works. Before we actually run that command, though, we need to quickly hit section 3, lamports-to-SOL math. We're taking a tiny detour here because blockchains, well, they process numbers a bit differently than human interfaces do. Wow, okay, that is a whole lot of zeros. 1 billion, to be exact. See, when you ask the Solana blockchain for a balance, it doesn't just hand you a nice, neat number in SOL. It gives you lamports. You can think of a lamport as the absolute smallest fractional unit of SOL. So if SOL is $1, lamports are the pennies. Except, in this ecosystem, there are a billion pennies to a single dollar. And honestly, this brilliantly illustrates the separation of concerns we have to manage as builders. Under the hood, the machine uses lamports because it needs safe, precise, deterministic arithmetic. But humans, we want to read SOL. So whenever we actually display a value to our users, we have to perform a simple division by 1 billion. If you forget this step, actually scratch that. When you forget this step, because we all do it at least once, your user is going to check their wallet, see this massive string of numbers, and totally panic, thinking they've suddenly become a crypto billionaire.
All right, we've got our wire, we know our tools, and we understand the math. Let's move to section 4, your first Web3 script. It is time to actually assemble the code.
I want you to treat each of these steps like you're soldering a vital component straight onto a circuit board. Step 1, we import connection and public key from the Web3.js library. Step 2, we instantiate our connection to point to our local or DevNet RPC URL. Step 3, we take a base 58 string, which by the way is just a standard wallet address, and we construct a valid public key object out of it. And finally, step 4, we call getBalance using that key, wait for the network to send back the lamports, and then we do our quick division by 1 billion. It is elegant, it's straightforward, and it absolutely gets the job done. Now, here's a crucial little detail. When you instantiate that connection, you'll notice a parameter called commitment level, and it's usually set to confirmed. Do not just copy-paste this blindly. This is an explicit design choice. On Solana, commitment levels dictate how finalized a block has to be before the RPC node hands you the data. The confirmed level gives us this perfect balance between blazing speed and strong state guarantees, which is exactly what we want for local development and displaying wallet balances. Okay, building is done. Now we shift to section 5, validating the setup. Any good engineer will tell you the job isn't finished until the bridge survives a stress test.
This is where we verify the truth. You run your script, and boom, it prints out one SOL. Awesome. But hold on a second. Now you need to run the exact same check using the Solana CLI. You type Solana balance, toss in your public key and URL. Now, do the numbers actually match? If they don't, here's a little pro tip. It usually means your local Node script is talking to DevNet, but your CLI is pointing to your local validator. It's literally like dialing the wrong phone number and wondering why your friend won't pick up. Always ensure endpoint parity.
Once the basic script works, we harden it. We take that fragile happy path code and we forge it into robust, production-ready software. How? Well, you validate your environment variables right out of the gate. You wrap your public key inputs in a try-catch block. So if someone hands you a bad string, you throw a helpful error instead of crashing the entire app. You deliberately choose your commitment levels. And pretty soon, you'll be extending this to fetch parse token accounts and wrapping the whole shebang in automated CI tests. Because, my friends, that is the workflow of a true professional. So, look at what we've done today. You have successfully built a robust working code bridge that safely reads data directly from the Solana blockchain. But right now, it is just a one-way street. If you really want to expand your Web3 toolkit, if you want to learn how to build secure transactions and master these concepts from start to finish, I highly encourage you to head over to forge.college. Check out the incredible educational resources we've built for you there. Keep building, keep verifying everything you do, and ask yourself this: now that you can read the blockchain, are you ready to mutate its state?